Welcome everyone. I hope you had a good start for this year's CppCon 2020. I hope you had a good first day. I'm looking forward for the rest of the conference agenda this week. And let's get started with another suite of interesting sessions for today. A short bit about myself. I've been working for a long time, building tools for developers mainly. Worked for a long time building tools for IT pros and sysadmins for packaging and provisioning virtual machines and enterprise infrastructure. I built developer tools, and recently I joined the Visual C++ team at Microsoft. So I've always been in the tools building side of the industry. On behalf of my team, I welcome everyone to CppCon 2020, and I invite you to join our Discord and specifically the special interest group channel for Visual Studio users. And each year we also run a survey to get to know the community, and I invite you to take this survey when you have the time. A bit of housekeeping at the beginning. Do ask questions as we go along. I'll keep an eye on the Q&A tab in Zoom, and feel free to add your questions or comments. Those are welcomed as well. And if I can address them live, I will. If not, I'll defer them to the end. And of course, you can always reach out to me on the dedicated channel on Discord for this session or in GatherTown. So I'm looking forward to interacting with you folks and hear about your experiences and questions. So let's get started with it. So I'll start by trying to get the bearings around our community, the C++ community. It's a very large community, and a quite vocal one when it comes to controversial issues. And people are very opinionated, and in many areas, even the most experienced members of our community don't always agree on best practices and the right way to evolve our language and libraries. So I'll try to instigate a discussion around several topics in today's session, and hopefully a friendly dialogue will come out of this, and folks will feel free to share their opinions and ideas and experiences. And the idea is, of course, being such a large community spanning many years of development and billions of lines of C++ code, we're a very fragmented community on many topics based on the breadth of the ecosystem and various parts and types of industry and various verticals. Based on our background and experience, we each bring from our C++ niche. So it is a fragmented ecosystem. We rarely see consensus around important topics. I would draw here a parallel to the classic elephant metaphor that Bjarne likes to use, but I'll have to throw in my special flavor here. Apologies to the vegans. So we each see a different side of what C++ is, and what best route to evolve it, and around what is best practice in our domains. And we have plenty of sources of good information, and easily available too. Nowadays we have the CppCoreGuidelines, we have lots of best practices, some of them very opinionated. We have established idioms, some old, some new. We still have plenty of good books around. We have tons of conference presentations, like we have this week long at CppCon, and of course Stack Overflow with endless source of minutiae and explanations and details on various questions. Fair warning, some of the stuff we find online might be in the hot takes category of opinions and idioms, and everyone has to judge for themselves if something is appropriate for their environment, for their context. So take it, don't take it at face value all the time. And mixed up with all this body of knowledge and information we have with good materials around, there's also plenty of myths still flying around. Some myths stem from obsolete information that is still around, some of it in books, some of it on the web, and unfortunately some of these myths stem from bad teaching materials. And speaking of teaching, this is an important subject for me, as I've been involved in teaching from time to time. And when I talk about teaching, I'm not talking exclusively about onboarding new folks starting to learn C++ or code reviews. I'm trying to have a broader sense of what teaching and onboarding on this C++ industry journey is. So some of the items in this list might seem silly or obvious to you, but I have heard them when I had discussions either with junior developers joining a team or interns fresh out of college that learned some certain things that might be a bit out of touch with reality of today's industry. And of course, questions I get when I lecture at my alma mater, and again and again. So I think it's worth discussing them, and it's worth it to have them out there, and it's an opportunity for folks to pitch in and contribute with extra information and extra explanations. So I consider this like a starter pack. If you want to learn a bit more, if you're interested about the teaching aspects, I did a presentation a while back, just a year back, seemed so long ago, about teaching in uni, teaching C++ explicitly, as I did guest lectures several times at my alma mater. And in terms of onboarding, in terms of learning something new, I think we've all been there, and it's always difficult to join a new context. Even if you're an experienced developer, joining a new kind of industry, a new kind of context, joining a new team, maybe with different constraints, requirements, it's always challenging, it's always daunting. And we tend to forget that as soon as we get comfortable and we gain more experience in our domains. And we have to remember to have patience with new folks, with new stakeholders or new team members, and don't dismiss their questions as silly or redundant or obvious. So the way we explain things sometimes makes us reconsider known idioms or known patterns. So I think it's a beneficial way of advancing oneself by mentoring and teaching others. And how it all started? It started with improv session, totally unscripted interaction that I did with Jason a year ago, where we set out to live code and discuss random aspects, random myths or ideas, and it was a totally improv thing where we started analyzing and dissecting various idioms and ideas, and ran through some code samples and see what conclusions can we draw. It's a bit long. I wouldn't necessarily recommend following this stream, but that was a lot of fun, and that was an inspiration for doing something more structured in a more condensed way, as I saw interest from folks that attended the stream back then. So the usual suspects, the usual verdicts, confirmed, busted, and the idea here is not an absolute labeling of a particular myth or a particular idiom. I'm not that interested in the exact label I'm going to apply here on this presentation. I'm much more interested in starting a dialogue and drawing attention to that particular idea, so that folks come in with their opinions, with their experience, with their corner cases, and I'm very much interested to hear other folks' ideas. So don't take the labels as absolutes, they're just for fun. And of course we have the always the staple response for a programmer: it depends. So we're gonna see that today too. So let's test this. If I were in a room here with the audience, I would make a real run for it. But let's see. iOS streams are slow. Just kidding. This is a confirmed thing. Everyone, I hope, agrees that iOS streams are not the best tool for performance when it comes to using any kind of IO in C++. Next up, C++ 20 modules will solve all C++ problems. I think I've heard this one a lot. And I kept hearing how modules are going to solve everything up until they were standardized. And yes, they're a great addition to the standard, but they're far from being easy to retrofit in legacy code bases. But there are success stories out there, and the most recent one was just published yesterday by the folks in the Office team, which is a fairly large code base, and they did a very interesting experiment where they actually tried to use to start adopting modules, and I encourage you to read the blog post to see their experience there. So gradually we're gonna see teams more confident in making the first steps in this direction, and but it's not what everyone hoped it would be. We're far from being in a perfect context there, but it will take time. Coroutines shipped in C++ 20. I put this one as plausible. Without real library support, yes, we're gonna get a generators library in C++ 23, but without proper library support, they're just building blocks. They're just low-level primitives, and for sure they're not really ready for consumption, as in a general audience kind of thing. So they will remain a very useful and powerful mechanism in the compiler that people can leverage and build their own libraries around. And if you duct tape enough glue code, you can get something working and have a performance framework there. But I think they're far from something usable for the general public. I like this slide from Kevlin from C++ on C a few months back. I think you got how this works. So this would be like kind of like a part 1 of N presentations, and I do invite other speakers to join in this myth busting series and come with their own myths, their own topics, and put them out there for people to discuss. I like the effective C++ numbering scheme, or for folks that still remember, the Guru of the Week kind of thing, where we used to know the particular numbers, like item 21, item 42. They had special meaning. We knew them almost by heart. So I went for something like that. So let's get started. Printf, Printf are very fast, and this one usually comes up as a response to people knowing to stay away from IO streams when performance is an issue, and they tend to go for these as alternatives. And sure, they are faster than IO streams, but what isn't? Actually, Printf uses the global locale. So this would involve the mutex lock, and for example on macOS, Printf, which is in system libraries, so you don't really have any control of that, ends up spending almost all of the time inside the locale related mutex lock. So this is a hot API. For sure, stay away from such things in hot paths. I saw a case study from Blender a while back about switching from Printf to lib format, and they got a 3 to 4x speed up on macOS and a 20% speed up on Windows. Well, the difference there being that on Windows it was already in a pretty good shape due to a better formatter, but it's a huge difference. So yeah, I do encourage people to use a standard format if you can, C++20, or standard print in C++23, or if that's too futuristic for your code base, then use lib format. So FMT is an easily adoptable library in any code base. So there's really no excuse for not leveraging something that is modern in API, flexible, and fast. And in general, be aware of standard functions that use the locale. I think there's not enough visibility there. When you survey the standard functions around the idea of I/O and strings in general, it's very hard to know without digging which ones actually reach out to locales and use locales. Next up, I want to talk about tools. Humans always depended on tools to get the job done, and I think successful and any successful endeavor depends on using the right tools to ease the work, to help with the work. And I've heard this time and time again, that C++ is not easily toolable. I told you at the beginning, I'm a tool builder. I always build tools, and I know what it means to build tools and work with developers that use those tools. The idea here is that we have lots of tools actually at our disposal, and all over the spectrum of use cases, from code editors and IntelliSense and navigation to linters, debuggers, refactoring tools, build systems, package managers, fuzzers, static analyzers, and profilers. We have tons of tools. The idea is that we have many tools, we don't have one tool. So We have great tools for maybe for particular operating systems, other great tools for another operating system, and we have open source and free tools. We have vendor provided tools. There are lots of tools. The idea is that everyone should survey and know what's available, what's out there, and try to see what fits their context, what fits their team and their project, and get to know the tools. We have to know the tools very well, the tools we choose to use, the ones that we consider are most appropriate, that bring the most value for our projects, for our teams. We really have to invest to get them, to know them, either to contribute to them, if they're open source, extend them. Many tools support like extensions, a way to extend them, or improve them, contribute if they're open source. If they're vendor provided tools, submit feature requests, submit bug reports, learn, read the documentation, learn all the secret knobs and secret switches and command lines and hidden panels and windows and so on. Learn, really learn to use it. More often than not, when I hear people complain about we don't have good tools in the C++ ecosystem compared to maybe other families of programming languages. More often than not, it's a case of people not doing the proper research to find out what the right tool is, what's available. So knowing about what's out there for a particular task, and not learning the tool well. So you might be stuck using a tool, and if you don't spend time to really master it, then really it's not helpful. Yeah. So spend the time to invest to know your tools and ask for improvements. Next myth. Standard Regex is too slow for production use, and I have here, I think, the simplest snippet I could come up with, where I do something meaningful with a regular expression. I honestly cannot think of something simpler than this that sounds realistic. And this very short snippet is actually so slow to compile, it times out in Compiler Explorer. And I couldn't make it work on the first try. So I remember when I did the improv session live stream with Jason, we both struggled like for 8 to 10 minutes to make this compile and figure out how to use the API without looking at the documentation. So definitely not the most inspired API design, and it's dog slow. So it's slow to compile, it's slow at runtime, it has lots of performance gotchas. For example, you have to be careful about the regex constructors, and even the cmatch can be expensive, so you have to be careful to hoist the variables at the right scope, so you don't pay for constructing these objects. So it really comes with a lot of gotchas, and it's just too slow. Unless you need the actual regex to be dynamic, user provided, you are much better off using a library like CTRE, and I think more people need to get to know this library. It stands for compile time regular expressions. It's very fast to compile. It's a much cleaner API. It even supports string view. It builds the regular expression automata at compile time, and it's very easy to incorporate in projects. So it's there's really no high barrier of adopting it. So I strongly encourage people to use this as an alternative. And no, we're not going to get this in the standard. Standard optional inhibits optimizations and complicates APIs. Boy, have I heard this one. I came up with a very, very simplistic example here. Let's say we have a function that yields an optional value of type string, and we measure that string to see how long it is. A very simple example here. And straight away, if we look at the compile program, we see that the getValue function, which is called by getSize, is automatically inline. So the compiler actually sees right through this. In this situation, the optional really is no real barrier for optimization here. The compiler sees through this and returns directly 5. So we can even spot the string literal there, nicely encoded. Hello. So in this simple scenario, it was actually straight through. The functions just evaporated. And let's say we want to get rid of small string optimization, and if we go for a longer string so that we force it to go to the heap, we see the string allocation happening here in the assembly. And again, the compiler sees right through it and inlines everything and spits out the length 23 directly without doing any extra work there. So again, the optional here is not a barrier for optimization in this example. However, if we do a slight modification, so previously we had returned the string literal directly. If we do a small modification where we hoist this into a dedicated string variable, which we call value, immediately we see a difference. We have roughly 40% more instructions there. And the idea here is that we copy construct a string. And this is a common gotcha I see around using optionals. And that is when you get conversions that you don't really expect. They're designed to work that way so that it works easily and it composes nicely, but it comes with a performance gotcha. So you end up, if you have a type mismatch, our function returns an optional string and we actually return a string. So in this situation, everything compiles nicely by design, but we pay for this conversion, and this is due to this constructor for optional. So I see this. It doesn't always matter, of course. Sometimes you don't care about such costs, but when you do care about such costs, and you identify such a hot spot and you point your finger at that optional, the optional is not at fault. The optional works as designed. The idea here is that we need to be careful to track our types correctly, to know when we're returning an object and it's returned as an optional of that object. So we need to be careful here. And the other side of the thing is that optional complicates, and it's related. Optional complicates APIs. So if we go beyond the perf issues, I hear that optional complicates APIs because people have a tendency to unwrap the optional when they pass it, or they have an impedance mismatch where they have functions that take the object by type and they have functions that return optionals of that object, and they struggle to compose such functions. So these are the situations where things get complicated if you don't have a good established way of dealing with such situations. So the recommendation here is don't look inside the box being the optional. Don't use optional for error handling, and don't try to unwrap it at every step. And when in doubt, always draw inspiration from other APIs in other languages. If you know Haskell or Rust, think about maybe and option types, learn from them. If you want to get a better understanding of how to use such concepts, I think it's worth investing in getting to know some functional programming concepts like fmap and applicative. And I have some recommendations here. The theory is complicated, but there are plenty of resources out there which are much more applied, much more down to earth and example oriented. And my favorites are this series of articles that I linked here in these slides, where they explain very complicated concepts in very simple terms using images and simple examples. And I think they're very intuitive to grasp for a person seeing these concepts for the first time. So the idea here is that we want to do some transformations where we have a value in a context. We usually call this a box. A context might be an optional in our example, and we want to do some transformations on that value without opening the box, without looking inside. So we don't want to unwrap the value, do a transformation. So we want to have some kind of higher order functions that help us apply these transformations from one stage to another and carry over this context. So we want to carry over this box that might have or might not have a value inside, and only at the end we're interested to see to unpack it. So we often end up with chains of functions that take and return optionals, and it's very tempting to check the value, to branch in a particular way to see if we have a value to this or otherwise to something else, but it's not the right way to deal with these APIs. A small aside here, this is all about boxes and lifting operations and higher order functions. So we always have to think about in terms of lifted functions or higher order functions. Instead of going from A to B as types, we have to go from optional of A and optional of B. So we have to always think in terms of mapping like function that helps perform this lifting operation. A very simple example here of an fmap function, for example, that takes an optional of A and returns an optional of B, and a simple application function from A to B. Or if you prefer the template version like this one. I won't go into details about this. I have a whole presentation. It's called The Imperatives Must Go, which goes into depth into some of these FP patterns and ideas that we can borrow from functional programming languages and use them effectively in C++. So if you're interested, check out my other presentation. Going back to optional, starting with C++23, we do have these monadic extensions to the optional, which hugely help us deal with composing such functions or composing such operations into a processing pipeline. So let's imagine we have a string view to int function that returns an optional int because we cannot always convert a string to an int. And we want to do something else if we succeed. So after we do the type conversion from string to int, then we want to do something with that integer value. So we use the end then continuation function and provide a lambda, and here we deal in terms of an integer value and an optional, we return an optional int. And I have a very simple example here which does some kind of clamping of the values. And after this continuation, we do a transform on the value, and again we provide a lambda which gives us the input integer, and here we log something, I guess. And in the or else case here we do some logging. So, and only at the end we actually pick at the value. So when we build a sequential stream, we build a sequential pipeline instead of a callback hell of inversion of control. So we have a linear like expansion of processing steps, and at the end of the pipeline we extract the value that we have there. So this is a way of easily composable compose APIs around things that might not yield values, so things that return optionals. So I would say the myth that optional complicates APIs is busted, with the caveat that we do need to learn to think differently. We do need to learn to use the proper constructs and use optional in the way it's intended to be used. Moving along, we have a tradition of good naming in C++, both in language and library. We have standard move that doesn't move. We have standard forward, which doesn't forward anything. We have standard remove, which doesn't remove. And standard function, which is not really a function. So I'll let you ponder those. But I'll focus on one of them, which I think surprises many people learning C++ for the first time, or maybe learning C++ 11 after years of traditional C++, let's say. And that is std move doesn't really move. And I have a simple example here, an echo function that takes 2 arguments by const string ref, and nothing spectacular here. When we call this function, we get hello from long string, hello from long string. So far, expected output. And then we try to move the greeting string, the greeting variable. We try to move it as the first argument, and then provide the same greeting variable as the second argument here to the echo function. And this is where people usually scratch their heads before understanding how move actually works and what move actually does, because they suspect that the move occurs here and then what happens to the greeting. And if we run it, we actually get the same result, because move actually doesn't move. Move is just a glorified cast. So I've actually seen constructs like this, and not into examples, where people actually use move multiple times when calling a function on the same variable. And this really freaks out folks who see it. And again, nothing different happens. And the idea here is that standard move, which adapts to an R-value reference here, which binds to a const string reference, that is our function signature for echo. And basically nothing happens. Nothing fancy happens. But I've seen people being tripped off by situations like this, and we really need to do a better job at teaching C++ and teaching move semantics. If we change, if we remove the references here in the echo function, then we start to see some changes, and this is a good way to learn and discover how things work, to just tweak the code and see what makes a difference. And in this situation, we see that we have the string on the left, first argument, but we lost it on the right, so it's no longer there. And the idea here is that we no longer have a reference in the echo function, and we actually call the move constructor for standard string, and we move in the value in this first argument. And of course, after that, the greeting is a moved from string, which is empty. And this happens on Clang, and if we switch to GCC, it's fun, it's the other way around. And this is just related to the order of evaluation for function arguments. So just playing with the example, we get an idea of how things happen and what move actually does, and when the move occurs. So related to this, a usual thing we learn is always pass input arguments by const reference, and we already saw the function echo doing just that. And this is the traditional way we design functions. And let's say we have a widget and we provide two constructors, one that takes a const reference and one that takes an r-value reference. And this would be again the canonical thing you see when learning about C++11 and move semantics. But things really derail if you want to go for the full performance. Things really derail when you have multiple arguments for your constructors. So it's a combinatorial problem here. Of course, even for two arguments, it gets really messy. And a pattern, a newer pattern that emerged here that not many folks are familiar with is the sync pattern, where we want to take ownership of the arguments there from the constructor, and we sync them because we take ownership in the widget object. So we sync them, and then we take them by value and move them in the right place in the destination in our widget. Again, I've seen people look weird at things like this because they don't spend a bit of time to try to understand how this works in every situation. Even for setters, same pattern applies. If you take ownership of that and sync it in the widget, the same idea. And if we take some examples here, for example, we have a string literal in a setter. We create the string with a string literal value and do a move assignment into the data member. If we change it and hoist it in a string variable, then we create the string with a string literal value. We make a copy of the string and we do a move assignment into the data member. So these are the operations that we can track down. If we change this to a standard move, so from set name to set move name, then we create the string with a literal value, we move construct the string, and we do a move assignment into the data member. So if we want to have the separate approach to have the overload set of the two setters with the const string ref and the r-value ref, then we create a string with a literal value, and then we make a copy of the string. So the idea is that technically this variant is more efficient because we have one less move operation. And if the move operation is expensive for the type you're using, then yes, by all means, this expanded overload set is more efficient. But if the move is not an expensive operation for the type you're using, then the simpler API is definitely more readable and maintainable, and the performance might not matter there. So I would say more people need to be aware of this pattern and understand when it's appropriate to be used, because it really saves a lot of boilerplate. And there's even a clang-tidy modernizer check to perform this transformation at scale. So, for example, if you want to embrace this pattern, you can actually automate such transformations with clang-tidy. There are plenty of materials on move semantics in C++. There's even a very big book that goes into a lot of detail, and I think it's worth it. If you're pursuing really performance in every corner case and you really want to understand all the underpinnings of all the situations, you really have to spend the time to dig through some examples and understand the rationale and how move semantic really works. But definitely it's not a beginner-friendly topic. Moving along, the next one, the next myth, adding const always helps. We always like to say we like const things, const all the things. We like to say that we got the wrong defaults in C++. In many regards, yes, it's true. But there's danger in you over-abusing const. And Jason did a very nice C++ weekly episode dedicated just to this. Just to summarize, top 4 places to never use const. Don't use const for non-reference return types. Don't use const for local values that need to take advantage of implicit move on returns. Don't use const for non-trivial value parameters that you might need to return directly from a function. The idea is that using const might inhibit move on returns or RVO. So need to be mostly move on returns. The idea is that you can really sabotage yourself by adding a const that doesn't really bring any value. Mostly in terms of function scope and in terms of function arguments or return values. And don't const member data. Surprisingly, this is a thing that I've seen quite a few times. Const data members break implicit and explicit moves, and most common use cases of assignment. And in some situations, it even complicates constructors. So I would say always adding const. I put it in the busted category, but the idea is that like anything, abuse of any feature is not good. We really need to understand what the consequences are. The next one, make all data members private. Typically seen as a good practice. This comes from the O heritage. Enforces encapsulation, object is in control of its internal state, all that goodness, solid and so on. But not all types have invariants to enforce. Over encapsulation and making all the things private and adding boilerplate getters and setters all over the place without having any invariants to protect or enforce, it's pointless and can be detrimental. When we do have invariants to enforce, we need to document those invariants, and then we have to provide proper access. But it's not always the case. Sometimes it's just a matter of inertia. People just code that way because this is how they learn to code, and they think it's a universal best practice to encapsulate everything in this way. So we do have to think about narrow and wide contracts and about invariants and properly document them and enforce them when needed. But just blindly following this mantra of making everything private for the sake of future-proofing something might be detrimental today. So, and it adds complexity. In general, just adding all the kitchen sink utilities to a class just because it might be useful in the future, it's not always the best approach. So we have to generally strive to write simpler classes, and we might not even need constructors. So we need to think about that too, because we often have the tendency to add constructors by reflex, I would say. sometimes structs just want to be structs. So I think structs are good. I very much enjoyed the presentation that Kate Gregory did at the ACCU this year on abstraction patterns, and it's related to the idea of encapsulation and how we present and abstract away our types and how we present them to be consumed. So I do recommend this presentation if you want to learn more. And yeah, sometimes structs just want to be structs. And while we're on the subject of structs, I couldn't help myself to point you to Mike Acton's data-oriented design in C++ keynote. An unpopular opinion in the C++ community, I know, but I still think that Mike Acton's keynote from CppCon 2014 is one of the best CppCon keynotes ever. I still remember the audience reactions. The idea is that the gist of the presentation is that software is about processing data, transforming data from one format to another. So we have a data processing pipeline. It needs to be very efficient. And performance is all about smart data layout and memory access patterns. So if you really care about squeezing every bit of performance, you have to forget fancy constructs and think about how you lay out the data and how you optimize for the transformations you're going to do on that data and the memory access patterns. And sometimes a struct is the best way to do it. If you want a more recent take on this, I do recommend this presentation, A Practical Guide to Applying Data-Oriented Design by Zig creator Andrew Kelly. I think this presentation channels Mike Acton very well, and it's a modern take and a good case study using the Zig compiler. So highly recommend it. Moving right along, iterators must go. This is an older one and stems from a highly influential talk in our C++ industry from Andrei Alexandrescu back in 2009. And I always heard this talk presented, referenced, folks arguing about, writing about it, never found a recording of it. I wasn't there. And I finally managed to find the recording, and I put the link here in the slides if you want to watch it. It was a highly influential presentation. It really changed the industry and the landscape, and it influenced other programming languages, of course. It influenced the ranges, it influenced Rust, and even C++ today. So the idea is that most folks think that ranges will completely eliminate the need for iterators, and that iterators have no place in modern programming, at least in C++, because we have ranges now. I'm not a believer. I'm not in that camp. I remember Alexander Stepanov was really infuriated about this popular trend on the ranges bandwagon, and he used to say that Alexandrescu is not on a crusade to eliminate iterators, his beloved iterators. This is in Programming Conversations lecture series from A9. I've put the link there if you want to see. It's a beautiful lecture series. Ranges are a fantastic addition for our algorithms toolsets, and in the imperatives must go presentation, where I go into functional programming patterns and how we can use functional paradigms in C++. I do go into depth and praise ranges for what they can deliver for C++. But iterators are here to stay, I'm afraid. And somebody did properly destroy in terms of good analysis. Barry Repsin did a fantastic analysis of iterators and ranges, and it's a comparative study of C++, D, Rust, and C# and maybe Swift. No, Swift. I don't remember if it was Swift. So highly recommend this presentation. There are various formats of it. I think this might be the best one from CppCP from Paris. So very interesting comparison. I do recommend that you dig into this one. So I would conclude with an evergreen myth, I think. And that one is that new C++ is the enemy of the old. And I like this quote from Pablo Halpern. Before we had feature X, we were nonetheless able to program in C++. And we tend to have this mindset of what was wrong with what we had, and tend to reject novelty because we don't always understand the best use cases. So we have to think about how we retrofit modern concepts in C++, how we borrow things from other programming languages, and what the new best practices are. So this is a constant reevaluation process that we need to go through. And it's a learning process, it's a discovery process, it needs time in industry, it needs time to prove itself. Each time we enhance our toolset, each time we add something new and learn new ways, better ways to build things. So, like I said, this is a series. I invite others to join and come up with new things to discuss. I do recommend this one. This is a much bolder presentation, I think, of other programming myths by Patrice Roy. I very much enjoyed it. And in future episodes, these might be topics I will cover in future installments of this series. Enjoy the rest of the conference. Reminder of the Discord channels and the survey. These are the presentations my team does at CppCon this year. You can find the sessions listed here. We have a booth for the folks on site. Do come and chat with us. And I'll see the questions we have in the chat. What parts of C++20 are unusable to the common programmer? Good one. Coroutines. I think I wasn't too shy about specifying that. I see some comments. I should be using SN Printf anyway. Sure. What does using locale mean? This one had an answer. It's localization dependent stuff. Yeah. Each time you need to do any kind of I/O where formatting is dependent on culture and the current language that you need to output in. There are many functions which are sensitive to such formatting conventions. So, but they're not always visible. These C++ API kind of functions, or the ones that we had from the C library, they're not always obvious they use such locales. Whereas IO streams are very explicit because they have the locales, they have facets, they have them encoded in the API.